Welcome back. Pretty sure we have the audio. And we're going to finish the day with this example. We're going to draw all possible isomers with the formula C5H12O. I just want to make sure everything's where it should be, and it looks like it is. There we go. C5H12O. Earlier on, we discussed the nature of oxygen. You do not have the option of changing the nature of oxygen. You need to have oxygen with 2 bonds and 2 lone pairs. Although this is not a Lewis structure question, so unless you're asked a Lewis structure question, I do not need to see the lone pairs on oxygen. So what was my strategy before? It was to draw a straight chain with all the carbons in it. There's 5 carbons. Now ask yourself if one of those is bonded to oxygen, how many ways can you do that? So now if I put an oxygen in this corner, you don't have 5 carbons anymore. So let's explore that later, please. I can attach a new bond to oxygen here for 1 molecule, a new bond to oxygen here for a 2nd molecule, and one in the middle for a 3rd. Don't do one on the 4th because that's the same as the 2nd. Don't do one on the 5th because that's the same as the end. I need 2 more copies of my stick figure. And that will let me finish, and let's see who's been paying attention. If you think you're done after you do this, you're in trouble. That is not the end. The nature of oxygen is to have 2 bonds. The nature of stick figures is to have only H's off C missing. So this O has to have an H or else you just drew it incorrectly. Next week, you're going to learn that's a primary alcohol. Do not worry about that today. That one next week, you're going to learn is called a secondary alcohol. And down here, a different secondary alcohol. So that's all the alcohols. Don't worry that they're alcohols. Those are all the molecules that have 5 carbons in a row with an OH sticking off one of the carbons. Okay, what did we do next previously? We looked at 4 carbons in a row. 1, 2, 3, 4. How'd you get the 5th carbon on? Well, you had to use a branch. So instead of sticking the 5th one off the end, you stick it there. In fact, in this question, let's have the strategy. Let's do all the molecules that have OH first. So we'll only focus on molecules that have OH, and then we'll move on to a different type of molecule where the O has carbons on each side. All right, so how many ways can you put an OH on this guy? You can put an OH here, and if you do that, wouldn't that be the same as putting the OH here? So let's have a separation area and do just what I said. Well, before I do that, I know I'm going to need this skeleton more than one time. Sadly, on tests, you can't do this with pen and pencil. Copy. Paste. I'm going to put a 3rd one over here. Not unique. Putting it here is the same as putting it here. And let's just go 1, 2, 3, 4, 5. This is the same as 4. Not unique. Okay. You could have put the OH off this one. There's room for a 4th bond there. You could have put the OH off this one. And some of you might initially say that, hey, this is not unique. You're putting it off the end again. You did that already. But I want to point out the end on the right is different than the end on the left. Oh, don't worry about listing it OH or HO. They are the same thing. But this end is very different than the other end, because this end goes to a C that's got 2 bonds to C. This end goes to a C that only has 1 bond to C. Makes them different. So far, so good. We got 6 and 7. Okay. So do you remember your strategy for doing the C7H16? After you did 4 carbons in a row with a branched carbon, let's do 3 carbons in a row with 2 branched carbons. Remember, you couldn't do this. That'd be the same as the skeleton we just did. 3 carbons in a row. And the only place to put the branch is here. So there's 5 carbons. And I think I'll draw 2 of them like that. But one of them is going to go to the right of our red line, because you're not getting credit. Those CH3s right now, CH3s all the way around, all 4 of them are identical to each other. Putting it there would be the same as putting it on any of the others. Don't put it in the middle. You don't want that OV. You don't want to put an OH there to get an OV warning. So I think we have all the alcohols. Yeah. We have 5 in a row. And we have 4 in a row with a branch off the second, which is the same as a branch off the third. Don't do both. Then we have 3 in a row. Now I'm going to go back to 4 in a row, and instead of putting an OH, I'm going to put the 5th carbon attached to the O on the other side. What do I mean by that? Let's do 4 in a row, then attach the O, and attach the 5th carbon. Yep, oxygen can do that. It doesn't have to have bond to H. It can have bond to OH or C. And make sure it's got the right formula. C5H12O, 1, 2, 3, 4, and 5. H12, we got 3, 5, 7, 9, 12. And that one fits. And just like before, there's 4 in a row with the OCH3 off the end carbon. How about 4 in a row with the OCH3 off the second carbon? That's different, isn't it? That's different. Okay. Now, when you did 4 carbons on one side, did they have to be 4 in a row? They did not. Could be 3 in a row with a branch there. And then you're going to attach O, CH2, CH3. How many ways can you do that? I think just 2. You can do OCH2, CH3 like this. Off the middle one. CH2, CH3. Or off the end one. Putting it off any of the other ends is the same, isn't it? That's the same as the second one there, which would be 9, 10, 11, 12. That's number 12. This was number 8. Number 4. Not unique. Okay. And we haven't done any examples. Let's see, we've done examples with O attached to one C on one side. We've done examples with O attached to 2 C's on one side. And how about 3 C's one side, 2 on the other? I don't think we have any of those. 3 C's on one side, 2 on the other. That fits too, doesn't it? Now, did it have to be 3 in a row? How about 2 with a branch there? How you like that? I know a lot of you have apprehension right now, saying, oh, what happens if I miss one on the test? Your goal when you hit this question on the test is to just draw as many as you can. Do not worry if you miss 1 or 2. You're getting points for everything that's unique. You don't have to get all of them to do well on the test. I haven't told you yet, but there's always extra points available on these tests. A lot of extra points. You don't have to get them all to get 100. That's not on the syllabus, but I'm telling you right now, it's always been that way with me. So get as many as you can. And I think we've had a pretty good first day. If you can think of any others that I missed here, please email me and I'll do some kind of an addendum and make sure everybody knows. So these notes, the ones that I scribbled on here, that's going to be a document. You're going to go to the bottom of Moodle. There'll be a brand new area. It's section 28. It'll have Fall 2020 lecture in the title. So this will be there. The very first item in that new area is going to be a list of all the videos, and one of the early items is going to say Zoom lecture 8/31/20. So August 31st, 2020. And it's going to be broken into 4 segments. It'll say segment 1. Here's a link. It'll be a YouTube link. You go straight to that YouTube link and you can look at the videos that we made today. Please, feedback, suggestions, be constructive always. I know some of this stuff might have not gone as smoothly as you would have liked, but always constructive. We're working on making this better together, okay? We want it to be the best thing we can use possibly for learning. So email me with suggestions. My mailbox gets full, but you know, I look at them all. And welcome to organic chemistry, and I will see you Wednesday, hopefully. I realize some of you can't make the lectures, but I did want to provide them at 2 different times of the day. For some people that can't make the one time, they can at least get half the lectures in. None of the lectures are mandatory, and I hope you find these videos do catch you up as if you were there. All right, so take care of yourselves, and goodbye for today.
All right, thank you.
You're welcome.